Hey everyone, we are back with another problem on the InterviewBit series for the topic arrays. So the problem is called maximum non-negative subarray. Right, let's read the problem first. Given an array A of integers of length n, we need to find the maximum sum subarray of non-negative numbers. The non-negative numbers, we can also say it as the positive numbers. So we do not have to care about the negative numbers here. We just need to check only the positive ones. Okay, let's move further. The subarray should be contiguous, blah blah blah. Great. And maximum sum subarray is defined in terms of the sum of elements in the subarray. So whatever maximum subarray you would be taking, how is the maximum defined here? So the sum of elements inside the subarray should be maximum, and your subarray can only consist of the non-negative numbers, which can also be said as the positive numbers, right? We need to find and return such subarray. Also, few things to note here is, if there is a tie, then compare with segment's length and return the segment which has maximum length. Okay, fine. And if there is still a tie, return the segment with minimum starting index. Okay. Okay, let's see the test cases first. So we have an example here, 1 to 5 minus 7 to 3. So here the maximum sum subarray would be 1, 2 and 5. The sum here is 8. Okay, another positive subarray which I can see here is 5. Okay, but the maximum was 8, so our answer is 1, 2 and 5. You need to print the subarray. Okay, perfect. Let's move on to the next test case, which is this. So here one subarray I can see is 10. So here the sum is 10, minus 1 is a negative, so we do not have to consider it. 2, 3, this is a subarray, and here the sum is 5. And next positive element and the whole subarray belongs to 100, and here the sum is 100 again. What is the maximum out of these three? It's 100, so we return 100. Okay. Okay, so how do we approach this problem, right? So few things to keep in mind is, we need to figure out the maximum sum of the subarray, right? We need to figure out maximum sum, and we also need to print the subarray. So I'll only be able to print if I know the index of the start and the end of the maximum subarray, right? So let's take two more variables, which is called max start and max end. What is max start and max end? It denotes the index of the starting position of the maximum subarray, and the maximum end or the max end denotes the ending position of the maximum subarray. Alrighty. Okay. So let's consider a dry run on the same test case. We have 1 to 5 minus 7 to 3. Okay, I also need to maintain a variable called sum to maintain the running sum of the subarray, right? I'll assign it to 0. Let's say the maximum sum to be -1. Let's call the maximum start to be -1 and maximum end to be -1. Okay, or let's just assume it to be 0, right? And let's just assume another variable called start, which defines the starting point of a subarray to be 0. All right, let's walk through the test case now. So this is a positive element, right? So we do need to consider it. So we'll take its sum and we'll update the sum to 1. Okay, perfect. Now what happens is, we have got a positive subarray and it can be treated as a maximum sum subarray, right? Because our current sum is greater than maximum sum. It is greater than maximum sum. So it is the time to update the subarray. So how do I update it? If this is the case, if this is the case, then what I need to do is, I'll say that my max sum is equal to the sum. Okay. Perfect. Also, few more things which I need to do is I need to assign the max start and max end. So max start is going to be the start, the current start, and max end is going to be equal to the current index at which we are traversing, right? But this only happens if the current number is a positive number or a non-negative integer, right? What if it is a negative integer? We skip it, right? We skip it. It only happens when it's a positive integer. So the thing is, if it's a negative integer, we just skip it, right? This only happens if it's a positive integer. If a of I happens to be positive, then only we do this, right? Else else what do we do? Else we skip it, right? Also, sum plus equals to a of I, right? We take it, we compare if the current running sum is greater than the maximum sum. If yes, then we update it. Great. Else what do we do? If a negative element is encountered, that means the subarray or the non-negative subarray has to end, right? And in that case, its sum is going to be 0. And what would be the value for the start? So if you encounter a negative element, right, so you cannot treat it as a subarray. So the start is going to be the next index of the negative element. So in this case, it's going to be I plus 1, right? This is the basic pseudocode. But wait, we are missing few conditions here. What are the missing conditions here? What was given in the note? If there is a tie, then you need to return the segment with the minimum starting index, right? So there is one more case which you need to handle, right? So if the sum is greater than maximum sum, then anyways you need to update the maximum sum subarray. But one more case would be, or if the sum is equal to the maximum sum, if the sum is equals to maximum sum. And one more thing which we need to check is we need the longest one, right? So how do we decide the longest one? And we'll somehow figure out the length of the current subarray is greater than or equal to length of the max or length of the maxi. In that case also we have to update it, right? Since we are given in the note that if there is a tie, then compare with segment's length and return the segment which has the maximum length. If the sum is equal, the first priority we have to give is to the segment with the maximum length, right? So we are comparing the length. Also, if there is a still a tie, then return the segment with the minimum starting index. Okay, so this satisfies all the possible cases here, right? So now you have got max start, you have got max end, so you've got everything. Okay, so this was the pseudocode for this solution. And what is the time complexity for this? Since we are traversing the array only once, the time complexity is going to be big O of n, and we are not using any external space, so it's going to be O of 1 or a constant space, right? So again, it was just a proper implementation problem. You just have to ignore the negative elements and only consider the positive elements. There were few base cases, like if there is a tie, then what do we need to consider, right? That's it. Now let's move on to the coding part. Okay, so let's code it up really quick. Right, so we have given an array. So let's just first take the length of the array, which is n, and it's going to be a dot size. Right, now we need to maintain few variables. So for I'll show you the constraints. So it has to be minus 10 to the power 9 to plus 10 to the power 9. So let's just maintain a variable, and just for precision I'll take long sum is equals to 0. Also maximum sum is going to be -1 for now. Okay, let's just have a start variable and assign it to 0. Also I need to track the maximum sum subarray, so for that I'll use a variable max start is equals to 0 and max end is equals to -1. Right, so now let's iterate through the array. Okay, so the first thing which I need to check is if the current element is positive, then only I have to do something. Otherwise I need to skip it. And in this case the current sum is going to be 0 because I need to fully skip that subarray, right? Okay, also the start point is going to be the next index of the current negative element, right? So that's it. And for here, now what you need to do is, if it's a positive number, just assign it to the sum. Okay, we'll add it to the sum. Right, now we'll check if the current sum is greater than the maximum sum, or so this is the first condition which we need to check, if the current sum is greater than the maximum sum, or if there is a case of tie, that it can be equal, right? So if the current sum is equals to maximum sum, and we, in the case of tie, what is the first priority? The first priority is return the segment which has the maximum length. So how will you get the length? So the length of the current element, the length of the current subarray is going to be the current index minus the start. If it is greater than or equal to what is the maximum sum subarray we have, so what is the ending and starting points? It's going to be the length is going to be their difference, right? Perfect. So if this is the case, then we need to update the maximum sum is equals to current sum, maximum start is equals to start, and maximum end is equals to end. Okay, so if the current sum happens to be greater than the maximum sum, or this means that there is a case of tie. If there is a tie, then we need to check that if the sums are equal, then we need to get the longest one. How do you get the longest one? By comparing both of their lengths, right? Perfect. So now we have got the max start, we have got the maximum end. So now we need to print the subarray, right? We need to print the subarray. So how do we do that? So we'll just maintain a vector in ans, and we'll say, we'll iterate from maximum start, we'll go till maximum end I++, answer dot pushback a of I, return answer. Perfect. Now let's just run it. Okay, so the trivial cases are passed. I'll submit it. Okay, so it has passed, looks good. Perfect. So we have covered this problem called maximum non-negative subarray. I hope you guys understood it. Perfect. I'll meet you guys in the next video. Till then, take care. Okay, chalo, bye.